today's episode, we have Paco Nathan to talk about his latest foray into the world of graphs. And this episode will be anchored by our managing editor, the fabulous Jenn Webb. Take it away, Jenn.
Thank you, Ben. So we're going to spend most of the episode today talking about graph technology. But before we get into that, Ben and Paco have been hard at work on the next installment of the NLP survey report, which is following up from last year's survey. Ben, do you want to share some of the juicy bits with our listeners?
Yeah, so just a quick note. I'm not sure by the time this episode airs if the report will be out, but it will be out shortly. It'll be out in September for sure. So the best way to get a copy of the report is probably to subscribe to our newsletter, and you can do that by going to gradientflow.com/subscribe. So I think, and Paco can also weigh in here. I think the survey results are somewhat of a continuation of some of the things we saw last year. One thing I will point out is that last year when we conducted the survey, it was pretty much in the middle of lockdowns and the pandemic. But yet, even then, we saw the NLP budgets were growing, at least based on the response of the people who held technical leadership positions. And this year, that trend has continued. The technical leaders in our survey have signaled that NLP budgets are growing and growing faster than they were last year. So maybe this kind of relaxing of pandemic restrictions, at least in many countries, has contributed to this.
What were some of the highlights for you, Paco?
Well, I think it's really interesting to see continuing trends. Certainly, there's a lot of named entity recognition and entity linking. When you look at the main types of NLP use cases, you can kind of eyeball it and see, okay, well, definitely the de-identification, that's probably the healthcare people. But then when you get into a lot of these other areas, I think in general, we're seeing people are parsing a lot of PDFs and they're doing named entity recognition and entity linking so they can, hook in the results of NLP into some kind of knowledge base and use it. Also seeing a lot of summarization. So I guess my take is I don't really read this as like a lot of emphasis on like chatbots as much as, say, parsing a big stream of documents. And that's actually one of the learnings of the pandemic is just how crucial that kind of parsing of documents can be.
Oh, Jenn, one more thing. As Paco was talking, I was reminded. So one thing we've seen in both surveys, 2020 and this year's survey, 2021, is that people are putting a lot of emphasis on tools that they can tune and customize. Because as Paco will attest, there's so many pre-trained models out there. You can actually get started right away with NLP. So the question always is, how can I tune this so it works slightly better for my specific domain or use case? And there's not really good tooling or instructions, or the libraries themselves provide some instructions, but I think there's an opening there for someone to really simplify this across libraries. Just basically, here's I don't know, as Paco mentioned, named entity recognition model. It works, but it's not working well enough that I can actually use it seriously. So can you give me detailed instructions or a workflow to tune it, right? So,
or for your given use case. I mean, if you're an insurance firm and you're, parsing 50 million policies, you're going to have a very different concern than somebody who's got a call center. So I mean, one of the points we made last year was, when you look at natural language workflow, there's a lot of stages, a lot of steps, and there's machine learning at almost every step. And if you really get into these big use cases, you probably want to custom tune at each stage for what you're doing. And one of the big things that's happened this year, of course, we see this uptick from like Hugging Face and a lot of really sophisticated modeling. Those can be inserted at the different stages. And, we see tools like Spacey and Flare and all these others. But I mean, they've really taken this notion of building out components. I know a lot of the latter releases of Spacey, a lot of the changes to the API have been specifically about building customized pipeline components.
Yeah, and then there's definitely a lot more models than data. So basically, many of the models obviously used the benchmark data sets or public data sets, so they may not actually be suitable for what you want to do. I mean, if something is trained on newspapers or Wikipedia, and as Paco pointed out, you're in some area of insurance,
Yeah.
it's just not going to work as well.
There's much more tooling popping up that allows you to do kind of the human in the loop sort of labeling. So if you start out with a small data set and maybe you're doing some type of active learning pipeline, you can help guide the models toward better outcomes. And I think that for a lot of use cases in industry, they're not going to have Google's multi-year curated mountain of data, labeled data. They're going to have smaller data sets to work with initially, and they have short timelines to reach some kind of revenue. And I think that that's going to be a lot of the shape of things to come.
And as Ben pointed out, the report may or may not be out when this airs, so definitely subscribe to our newsletter, but also remember that you can find all of our reports at gradientflow.com/reports. So yeah, now let's turn to the graph technology topic. Paco, you have been writing a book. Is the working title Graph Thinking? Is that correct?
Yeah, the cat's out of the bag. Certainly.
Oh.
No, that's great. That's great. I sort of told the publisher that was, they had some other prospective titles, and I told them that's what it was going to be. So yeah, let's put a stake in the ground.
Okay, excellent. So can you bring us? Oh, go ahead.
Well, I'll give a shout out. There have definitely been some other people who've used that title for chapters and for talks, and I have colleagues who are at Neo4j and DataStax and others, and I want to shout out especially Denise Gosnell and Matthias Bruckler. They've done a lot.
But the key is there's no book yet.
There's no book yet. Yeah, we've got the book that pulls in not just the graph thinking, but also the use cases and the open source and on and on.
Are you the sole author?
Well, so that's really interesting. Yeah, the way this worked out is I've been leading a natural language open source project that's kind of getting popular. We're up to 1,600 stars on GitHub, which I guess there's others that are a lot more popular, but still it's been around for like 5-6 years, and we've gained a lot of developers, and it uses graph algorithms for doing entity resolution, if you will, entity extraction and entity linking. So I've been doing that for a few years, and almost a year ago, I decided, gosh, there's all these different pockets of graph technology, but the people working in them rarely talk with each other. So if you're working in graph algorithms, you're over in one direction. If you're doing visualization, you're in another. If you're doing probabilistic graphs, you're in another. If you're doing queries, you're in another. And there's nothing really. It's for those of us who try to make use of more than one of those libraries, there's always a lot of work to do, integration and testing. So about a year ago, I started a project and got some other people involved. I'm very grateful for the other developers on the project. It's called KG Lab. But we started building an integration of like a dozen plus other libraries in Python, and then building out paths so that there's an abstraction layer so that it looks very much like the rest of the sort of PyData data science tools. So it fits very well with things like pandas and Parquet and scikit-learn, because before this stuff was just all over the map. So we started doing that about a year ago and doing a lot of conference workshops about it, and kind of gained some momentum and some use cases. Started talking with people in industry. They were using it, but they were also interested in what could be added or really what they needed. And I got involved with some manufacturing firms, talking with them, and in particular, company I'm with has been consulting for a large manufacturer in Germany, and really looking at what they needed and doing very much of a deep dive across the vendors in this space, and kind of coming up to the conclusion that there's a lot of great open source. Let's integrate it for what we need, because we couldn't really buy anything off the shelf that would fit these billion plus entity graphs that the manufacturing firms tend to have. So I guess what I'm saying is there's a book in progress, and I've been promising that to the publisher for a while. But there's also an open source project that started out and a community around it, and a few graph conferences we're involved with. But then there's also some commercial use cases, large practices that we've been involved with, helping them to level up. And at this point, what I'm writing is in combination with all the above. I mean, I definitely will shout out to my colleagues, Francois Scharf and Thomas Steele at Knowledge Graph Conference, and George Anadiotis at Connected Data World. I've been doing a lot of work with them, and that shows up in the writing. Also, my good friend Jürgen Müller at BASF in Germany, and Janis Alez and the other folks there, Arnav and everyone, and doing some co-authoring with them, and you know, other places as well. So if and when the book comes out, it'll probably have a lot of accolades to other people as partial authors.
Nice. Well, let's catch up the listeners. Talk a little bit about what graph thinking means, and maybe a little bit about the trajectory of graph technologies and kind of the state of the space today.
Great, thank you. Yeah, you know, I mean, if you roll the clock back, let's see. So there's an earlier idea of something called computational thinking that came out of MIT way back when, like 70s, 60s, and 70s, and that was that really came to the fore not that many years ago. Janet Wang at CMU was really leading in the computer science department there to introduce this idea of computational thinking. When I was setting up training at Databricks, this was part of what we used as our rubric to reach out to people and think about how to use Spark. And so it's the idea of having a cognitive framework to approach a complex problem, and then sort of what's the recipe of how do I work towards solutions? And so you see that if you're talking about computational thinking and how to abstract the pieces together, like CMU and others use in their curriculums. You see that in terms of statistical thinking. A lot of my background, one of my degrees is out of a stats department at Stanford, and you know, statistical thinking is just so foreign to a lot of people, even to those of us who have degrees in that field. The idea of thinking probabilistically is actually kind of hard, and so there's sort of a cognitive approach that you can make sure, okay, let me level set my own, you know, focus and framework before I go after this problem. There's design thinking, there's all these different approaches, right? That sort of cognitive frameworks. So graph thinking is recognizing that when you have complex problems, then the way that people, I mean, not technologists, but people in general, when they have expertise in a field and they're going after something that's very complex, they tend to arrange their cognitive structures, if you will, organize their own internal knowledge in graph-like structures. And so, I mean, that's something that comes out of pedagogy theory. And, you know, when you're working with people who are beginners in a particular topic area, they start to learn a few facts. And then as they become more experienced practitioners, they start to piece the facts together, kind of like linear sequences of ideas. And when you get to people who are, you know, some pretty good practitioners, experienced, they'll tend to have more of like a decision tree view of the world, of how to organize the different facts in the field. But when you get to the experts, they tend to know where are the rules that you break and how do you break the rules, and where is it that like a decision tree view of the world just doesn't fit. And so they have a lot of links going back. And if you start to, I mean, the cognitive psych people, when they start to understand how people acquire expertise, they start drawing graphs. And similarly, if you, I almost hesitate to invoke this, but if you look at Dave Snowden and the guy, Dave Snowden and company at IBM Global Consulting, they came out with this idea of Cynefin framework back in the late 90s. And as many people know, it was quoted a couple years later by a gentleman who talked about unknown unknowns. So there's the known knowns, the unknown knowns, and the unknown unknowns. There is a framework behind that that's called Cynefin. It's a Welsh word that talks about habitat, I believe. And it's the idea that if you have a relatively simple problem to solve, you can just look up, you know, question comes in over the phone from a customer, you can look it up in a table and give them the answer, read it out loud. You can do a simple query in a database and just get the facts back and spit them out. When you get, and those are the known knowns. When you get into slightly more complicated situations, according to Knefin, then you need analysis. You can't just look up a fact and regurgitate it. Instead, you have to have people with a bit of domain expertise do some analysis. And that's sort of the data warehouse and business intelligence level of data view, where, okay, we've got some facts and some tables, but we're going to do some analysis, and then we're going to come out and tell the decision makers what we think they should do. But then when you get into a more complex kind of environment, there's no deterministic way to get an answer. You can't just run a program and get an answer. You really have to make some decisions. And this is where a lot of data science tends to live, because you have people in complex business situations and you're trying to use data to inform the decision makers, and they're going to have trade-offs, and they know it. There's no such thing as a totally fair algorithm in machine learning. We know that we're going to have to make some decisions and work with them. When you get into global supply chains, there's always weird, unexpected things happening. And so that realm of like the unknown unknowns is where you have to get in and start to understand, what are the emergent patterns? And how can I make sense out of the patterns that are there to be able to inform me about what kind of trade-offs, what kind of decisions I could make? And these days, business is much more complex. And so you tend to be more in that realm. And you tend to leverage more of this idea of shapes and patterns informing your judgments, your estimates. And so graph thinking is a lot of that, of recognizing that you're in a complex scenario and that you need to understand the connectivity of things, but also the shapes, the patterns that emerge within that connectivity. So, I mean, let me make this more concrete. If you're working in, say, market intelligence in enterprise, and you're trying to understand, why did we just lose that last bid for $50 million? And you're trying to trace down, who is it that won the bid? And then who owns them and who owns them? You get into a graph scenario very quickly. And when you talk with people who are professionals in market intelligence, they talk in terms of graphs. And when they're presented with graph technologies, they're like, oh, I get it. Yeah, that's exactly how I work. Unfortunately, when you go to people who are in IT and they're used to relational databases and you talk about graphs, generally about half of them will run screaming out of the room. So it's an interesting thing that the business needs are toward complexity, but a lot of IT shops are trying to drive the problems, essentially oversimplify them. And it works, and it works up to a point. There are definitely crises in business where you've oversimplified, you make the wrong decision, bad things happen. I wrote an article about a case study of sort of the end of AT&T back. I was at Bell Labs during, right after they spun out the baby bells, and that was definitely a case of where the analysis had come in, they oversimplified the problem. The executives gave up being a legal monopoly so that they could compete against IBM. They didn't realize that IBM was almost going bankrupt. And so they copied them all the way down and basically tanked the company.
By the way, just to affirm what you're saying, Paco, I think for our listeners, so who have heard about graph technologies and graph techniques, I just wanna affirm what Paco is saying, is that there are now a lot of evidence that this is advantageous and it works and the tools are getting better, and that unlike, I guess, the wave that happened maybe 6-7 years ago, the tools are much better now. Now, with that said, it will require a difference in thinking, as Paco was saying. That's why he's writing the book. And actually, I have a funny piece of evidence here, Paco, that I'll throw out at you, right? So one of my pet peeves is this file format that we all use called the CSV file, which everyone hates, but all the tools produce. It's almost like we've kind of are willing to suffer through this trade-off of human readability and writability, but sacrifice a lot of precision, right? So I think that if you talk to your colleagues about graphs, there will be some resistance. So you'll have to prepare for that.
I mean,
So if you can provide them with some evidence, you might be able to sway them a little better.
well, I mean, the thing that we see, so I've been doing a lot of use case analysis, and frankly, the material going in the book is just notes that from what the conversations we're having with executives and business leaders and whatnot, and IT and whatnot, as we're in progress. So it's a very hands-on, pragmatic thing. So, you know, as an example, if you're in a big company, you've probably got some kind of huge data lake, data warehouse thing going on. You've probably got Oracle or SAP somewhere in the midst of all this. And your executives tend to get, you know, aggregated reports. We've taken 1 million data points. We found the average. We make a nice chart for you. If you're trying to track down where a competitor shipped a very crucial container that kind of is the piece of the puzzle you need to find, those reports hide that. And that style of data analysis tends to hide the really individual things that are crucial.
Or even, Paco, what do you think about the CRMs? Those are perfect for graphs, right?
Yeah, well, so the larger
because
picture,
because there's a lot of things that you have to track that are relationships, right?
yeah. So the thing is, like, if you can take your customer relations and sales info, hook it into procurement, and then hook that into production, such that, you know, when there's a batch that goes out the door to a customer, you can trace it all the way back to where it came from and, you know, who weighed in on it. That gives you a lot better visibility to track down problems down the road. And at an executive level, that's really important, again, where you've got global supply chains that are constantly in flux and you're having to deal with it. And so as you're trying to understand risks and costs, and you're trying to understand really complex things like carbon footprint all across the supply chain, these are very naturally graphs. And the problem that we're seeing right now is, you know, it sort of begs that you would cut across the different divisions of a company and tie their data together in a larger graph to make a more larger scale decision. And so it's sort of the opposite of the data silos. And I think in some ways, the graph technologies are encountering similar problems as what the data mesh community is approaching right now. It's like, how can we break down the silos? What's a better practice?
But as you pointed out, the IT people that our listeners will be working with, they're all in the relational data warehouse world, right? So so you might have to come up with a way to get around them, at least in the beginning, when you're in the evidence supplying stage, right?
Yeah, and I've had that conversation with a lot of people who are colleagues who've been in this role. And, you know, the bottom line is you really need to go to some business unit where this makes sense and show, yeah, okay, this is a market improvement over what we were doing before. And this is able to do things that we can't do otherwise with our SAP or our Oracle warehouse. And then once the senior execs can see that, they give you air cover. And because this is typically a kind of practice that needs to spread wide. And for that, you need, you know, exec staff air cover. If it's something you're just going to go to IT and say, hey, I've got a new technology, I want you to adopt it and roll it out, they won't give you the time of day. That's been the experience over and over. And also just the problem is there are false starts. I mean, I won't mention names, but I used to work for an IBM executive who created some rather popular database, or had led the creation of some rather popular data frameworks. And he told me about how they had these kind of technologies at IBM decades ago. But part of the problem was they were like, you need to hire A students if you want to have them working with really complex tools that could be very expensive if done wrong. And a lot of big companies want to staff up. They don't want to hire A students. They want to hire the B students and the C students as well, because they can't do, you know, value added contracts with thousands of people otherwise. So there were determinations over the past decades that even though we are working with graphs internally, and frankly, any SQL engine is using graphs internally, we don't want to expose it because there's a danger that, you know, people who don't understand it could use it in ways that would become very, very expensive.
So what are some of the, for the CEOs, CXOs, what are some of the practical desired outcomes that are driving the enterprise adoption?
Sure. You know, there's definitely a lot of discussion about enterprise knowledge graph and sort of working from top down. I have not seen really good examples of this yet. I'm definitely engaged in a lot of that discussion, but I just haven't seen the examples. Mostly it's coming from mid-level execs who understand it and can leverage and then ally with other mid-level execs and then go to the top people and say, here's what we're doing. We need to roll it out. So I'll speak more from sort of building from middle out as opposed to top down.
Sure. That's what I meant. Like what do the middle take to the top?
Yeah.
Like what are the things that they're driving toward?
So when you're working with graphs, I mean, one thing is that when you see problems like complex disambiguation problems, or a classic example would be like transitive closure. If you try to run those in a SQL engine, you'll bring it to its knees. SQL is built for being able to index with normalized relations, tightly controlled relations across different indexes and tables. And if you take arbitrary relations within the same table and join it to itself many, many times, which is what you end up having to do with graph technologies, your typical SQL engine will just come crashing down. And so we see things like somebody will run a query and 42 days later, the query comes back. Whereas if you run it on the right kind of system, it might be a matter of minutes. And so, typical kinds of things. I guess I could jump into some use case analysis there. Novartis is a really good example. And so just make sure I'm pronouncing names correctly. Stephen Reiling from Novartis gave some really great talks. Both Cedric Berker and Stephen Reiling have been going out. One of the things that they struggle with is they build pharmaceuticals. And so you see a lot of graph technology used in pharma. The idea is most of the pharmaceuticals are dealing with a triangle, a geometric shape. In one corner, they know about molecules. In another corner, they know about genes. And in another corner, they know about diseases. And their knowledge is basically structured, their corporate knowledge is structured about that triangle and what kinds of molecules affect certain kinds of genes that affect certain kinds of diseases. And it could be that certain molecules cause the diseases, or maybe they prevent them, but that's their business game. And they tend to know the molecules better than the other two parts. And so Stephen Reiling has this brilliant set of talks where what Novartis did was they took this whole pipe coming out of PubMed and other sources of, the world's scientific knowledge that's being published, and they do some NLP, some entity extraction about molecules and genes and diseases. And then they just take a really simple trick. They do associative rules, sort of like the most bare bones machine learning you could imagine. But they build associative rules out of the entities that have been extracted for each document. And we're talking about hundreds of millions of documents coming through. And then they build up a probabilistic graph. And the graph says, hey, we've seen these molecules affecting these genes, which also has some effect on these diseases. And Stephen Reiling talks about how when they first did it, they went to their biologists at Novartis and they said, hey, look what we showed through inference using AI. And the biologists were like, we already knew that. Except for this 20% over here. We've never seen that before. Quick, let's go to the wet lab and we'll try it out. And so what they're able to do is convert their business. Before, their research was basically a scientist with a test tube and some compounds. And it was very serialized that way. And a scientist would say, oh, I think I'll test this. Let's see what the outcome is. Now what they can do is they can go in and take this whole huge stream of documents of all the data coming out of scientific research worldwide, and also for that matter, patents and what they have internally, et cetera. Build a probabilistic graph, knock out the parts that they already know about, the known knowns, and then concentrate on the regions of uncertainty in the graph, use that to drive and parallelize the research, which is what Novartis is doing. AstraZeneca, Roche, and others are also doing similar things. So this has allowed them to use machine learning to essentially parallelize life science research, and dramatic increases in the results, and fairly simple, not too much cutting edge NLP and machine learning. But I think from an executive view, this is how you tie the parts of your company together. This is how R&D goes into production and goes into patenting and all the others without having people running around. You can actually, focus on the areas of uncertainty that lead to potential profit. That's going back 100 years with Knight and early business theory. There's a notion of profit, risk, and uncertainty. If you know that you have risk with no profit in it, you buy insurance. But if you have areas of uncertainty, that's where the new profits will be found.
So Paco, that's interesting because I'm aware of a similar use case from AstraZeneca. So
Yeah,
it
AstraZeneca's
must be these pharma people are ahead of the curve. Now, another
Roche is doing that. Definitely finance, pharma, and manufacturing are the three that
yeah.
really talk about.
I was going to say finance has a long-standing
Yeah.
interest in this for Jen, for anti-money laundering, fraud detection are the classic examples there. But hey, Paco, I wanted to ask you about use cases that are closer to our heart, which is basically almost like you would call it data ops, right? So it seems like graphs are being used for like master data management, data lineage, access control, right? So metadata, which makes a lot of sense. So maybe this is the stealth way that you get these IT people to appreciate graph technology.
Yes, very well said. I mean, I think the two words are you have a complex situation in business and you have this problem of sense making. You can't take action until you can actually make sense out of what's going on, but it's too complex for that. So if you're thinking about master data management, but then how does that cross over into other areas of risk analysis and data governance, and then the security and threat analysis? You end up with a very complex graph.
Data where the tables are not going to cut it for that.
Yeah, your typical data catalog just it's too flat, too, again, Aristotelian. It's dealing with the known knowns. It can barely handle the unknown knowns, and if you throw the unknown unknowns at it, it falls over. So I have friends in the data catalog business, but they need to level up, because when you look at this area, we've talked about it before, but a couple of years ago, in response, or a few years ago, I guess 2018-ish, in response to GDPR, you saw very similar actions across the board at like 12 different tech companies. LinkedIn, Airbnb, on and on and on. And you saw these things like Marquez, which I believe was Airbnb and Stitch Fix, and I think Netflix.
Admonson, Data Hub.
Admonson out of Lyft, Data Hub. There's the other one at Uber. There's about a dozen of these. And Eugene Yao did the really great article about that way back when, cataloging those. But we've had an event series called Metadata Day, where we got the project leads from these different projects. Because they basically said,
I even advised one of the startups.
Yeah, exactly. There's like 3 different startups in this area: Stemma and Acrel and Metaphor.
Yeah.
So what's really interesting is collectively what these companies found was, wow, we need to be able to trace a graph of our data usage out to the customer in case compliance issues come up. And that's for GDPR and CCPA and all of these, India, Brazil, etc.
And also just data discovery. I think they found that a lot of their data people don't even know what data they have.
What Mark Grover showed with Admonson at Lyft was, once they got the system online, the first thing he realized was they were wasting about 30% of their data science budget, because you'd work on a project and then you put it aside. 6 months later, you come back to it, the data's changed, you have to go back and look up the metadata all over again. And so seriously, about 30% of data science time was spent just on data discovery over and over again. If they could put a nice UX with a search tool and a graph behind it for this in front of the data scientists, they recovered all the time. And if you look at the budget of Lyft and how many data scientists they have and how much they spend, they saved about $20 million a year just by putting the system online. But here's the punchline. Not only did they answer the risk problem, and not only did they do this cost saving internally, but once you start to have this kind of internal 360 on your data and where it's being used and who touches it, the next thing you realize is, wow, we could create entirely new product lines. And that's when the execs really come piling in on the problem. They're like, this is good, we want more. And so you see these companies, like you say, Metaphor and Acrel and Stemma and others that are going after that. And that'll be the thin edge of the wedge. Yeah.
So you both mentioned tools and talked a little bit about it. What are the state of the art tools right now? And do they vary by industry, or is it kind of the same across?
Yeah, that's what I've really been doing.
So I'll defer to Paco, but before I do, Paco, make sure that you realize that we have friends listening to this.
I know. Well, definitely, I have friends out of those product teams. So I'm in this weird spot.
You don't have to necessarily name names, Paco.
I'm on the program committees for like 3 different conference series in this space, so I definitely know all the vendors. I'm introducing their, CTOs when they go up on stage.
The
Yeah.
high level of where we are. Yeah.
Okay, so there are about 30 vendors in the graph database space. And they tend to follow along a couple lines. One is they're doing W3C semantic web kind of stuff, where you can do a lot of really interesting inference. And there's reasons, but they tend to fall back toward this old school thing called a triple store, which is just like, I have no idea why people are still doing this in the 2020s. And then there's something called label property graph, which relaxes some of the constraints and allows for really much better information management, but it doesn't really follow standards yet. And then there's other stuff that's just crazy. Like for instance, Facebook, I'm not gonna say bad things about Facebook. Facebook released this API construct called GraphQL. And it's because they use this API layer on top of their
Isn't that GraphQL is more like REST API, right?
Yeah, it's totally about an API layer.
Yeah.
But because it has the word graph in it, there's a whole bunch of IT people like, well, I know that GraphQL is the way you have to do graphs. And
Yeah, it's got nothing to do with graph.
Yeah, I mean, it is really brilliant once you've done your query and you want to send high performance data back. Yeah, that's great, and the reasons. But your typical IT person who's like read an article on Reddit or Hacker News, they're just regurgitating rant they read last. So yeah, there's also that part. So the problem is there's like 30 vendors, none of them are feature complete. When you go to the large use cases and ask them, what are you doing and what do you need? They inevitably come back and say, God, we've just had to patch it together because nobody really solves this. When I look at the largest use cases that are public, and this is not the tech giants, this is more, like I say, finance, pharma, manufacturing, and others. Definitely AWS Neptune gets probably a lot more mindshare than anything else. And it is one of the more general ones. Allegedly, Amazon acqui-hired the BlazeGraph team, and then they built this out. And that's the one that's certainly getting more airplay than anything else, but it doesn't solve everything. There's a lot of open source. And I've come to the realization, the other problem is this, that in distributed systems, there's this problem of scale up versus scale out. And a lot of what these people are talking about is scale up. And so if you were around during the early part of big data and you saw the transition into Spark, a lot of that timeline is being replayed right now. So, if you roll the clock back to like 2014, 2015, there were a lot of things called MPPs, which were basically somebody's relational database that sort of ran in a Hadoopish kind of way. And it had transactions and blah, 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 and it was a database. And I can tell you these things did not work well. In fact, I got hired to replace a lot of them. And then along came Spark and they said, we're not a database. We don't care about your transactions. You have a system of record to handle that. We care about your compute, and we're going to do horizontal scale out of your compute. And that is exactly where the graph space is right now. You have 30 vendors. Most of them are talking about asset compliant transactions and database management. The large use cases are like, we don't care. We already have much larger we need compute.
Just to clarify, they can do that as long as it's not distributed, right?
The moment that you start saying we're ACID compliant, it's like, and so that whole Spark argument of being able to scale out and do distributed usually is the thing that's sacrificed. And so we're seeing now what's emerging partly out of open source, but certainly led by some large use cases in China. When you look at what Jack Ma's companies have been doing, especially using Ray and other components, they've basically taken this to heart. They said, we have large use cases, fusion computing at Ant Financial, and we don't need your transactional database. We need scalable compute, and we're going to build it. And so, when I go and talk with the big manufacturing firms, they're like, we've been looking at China. We can't exactly use what they've built because they're not releasing it, but we can rebuild it. And so that's a lot of where we're at right now with graph technologies. But there's the other thing to understand. Dean Wampler and I just did a big report.
By the way, Paco, just to interject, Jen, one good sign in the space is that even though the companies, as Paco described, are still evolving and still have a lot of work to do, they're already getting
the valuations
pretty good revenue. I mean, the valuations are high, but some of them have high revenue too, especially if you compare them to like some of the AI startups, right?
No, there's serious revenue because
so that tells you that there is hunger.
Yeah, well, I mean,
what about I just want to ask a question that will fit into what you're talking about, Paco, but what are the differentiators between these tools? Like there's 30 vendors. So what are the considerations for a company between all these tools?
Definitely. Great. Well, yeah, so I've been, one of the things I've been doing is, curating a public spreadsheet that has a list of all the ones that I know about and can find, and then trying to break down what are the key features on them. And so one of the things is, are they doing scale up or scale out? So if you're doing scale up, it means you keep buying a bigger and bigger box, probably from Intel or AMD, and you end up getting, 128 core monster that costs you, you're going to end up paying six figures a year in cloud computing.
If you're used to working on a cluster, that's still nothing, man.
Yeah, but the thing is, there's very few that do the scale out thing, and so that's one thing we're like.
No, but when you say 128 core, that's nothing if you're on a cluster.
Yeah. Well, I mean, and one last thing I'll interject: if you look at the tech giants, they all talk about their graph practice, like across the board. Every tech giant has people out there giving great talks about their enormous graph, how crucial it is to business, and collectively, in about 2014, they shut up about any operational details. You will not get any operational details out of Amazon or Google or any of those. Amazon bought another company to build out their cloud graph practice. Microsoft Azure has been licensing from different cloud vendors to put their stuff up in the cloud, but they don't really have much of a managed service. Google does not have a cloud graph offering. And so it's really interesting because it's kind of turning out to be a secret sauce.
What about Paco standards? So what's
so
is Cypher the sequel of graphs?
So there's really three main query languages. If you come in from the W3C side and you want to be doing inference and you want to be doing closures and things like that, you're working in Sparkle usually, or Shackle, which is a shape constraint language that can be used for queries also. And then Neo4j had Cypher, and they have Open Cypher out, so a lot of people have adopted that. And then there's a more programmatic one, which is probably more powerful, really. It's called Gremlin. And so the problem is there are gateways to go.
So if you're a vendor, you're using one of those?
Using one, but you can't go between them. So right now there are gateways. If you have Gremlin, then you can bring Cypher into it, but not the other direction. And same thing with Sparkle. It's sort of, you can go one direction, but not the other.
Years ago, when maybe in their second year, the Tiger Graph folks were telling me they were going to try to do a standard. I don't know what happened there.
There is. So there are two main standards that are coming up. About 5 years ago, there was a fork off of Cypher that's now something that's an emerging standard called GQL. And that will be the thing, that is the one standard that incorporates all the other standards.
So controlled by no one.
Yeah, sort of. I think it's been 6 years. They're making some progress.
Who's behind it?
Just about everybody.
Okay.
And it does make sense because it would align the semantic graphs with the labeled property graphs. And then there's something called RDF star, where you can sort of do property graph-ish kinds of things inside of W3C. And the people doing RDF star, they're getting some traction, but then that's going to align with GQL. I'm not going to hold my breath. Frankly, in a couple hundred lines of code, you can rewrite a lot of the stuff these people are arguing over. So I think that there'll be other solutions that come out of open source long before those things materialize. But that's what the standards track is.
Is there a great graph database on a blockchain?
They're actually, no, I know. We love to laugh at blockchain. There's actually some really cool stuff on blockchain. You look at Flurry in particular and what they've been doing, very proactive, great developer team, great developer.
What do they do?
Flurry has, they can do both the semantic side and the property graph side, but then they can also take parts of it and have your accounting in a distributed ledger, do blockchain kinds of accountability. And for a lot of the graph applications, there are very natural reasons why blockchain actually would make a lot of sense. If you're tracking the carbon footprint in manufacturing and you have thousands of vendors and you need to track their supply chain as well, you need to have things like distributed ledger. There's just no way around it. And if you're doing financial transactions and anti-money laundering and all, that's another good reason why you want to cross corporate boundaries with something that's verifiable.
So let me up the ante then. What about quantum blockchain graph?
I have had that conversation. Yes. Well, so it's interesting when you build the internals of a graph compute engine or graph query engine. I won't belabor this, but I've spent a lot of time building those in different languages and different use cases. And inevitably you come up with these really enormous lookups for like unique symbols out to some objects and chasing down the relations. And so you end up with a lot of high performance computing with hash tables. And also generating a lot of random numbers, oddly enough, is kind of the bottleneck for a lot of this, even in a distributed scenario. So there are places where quantum would come in pretty handy.
You mentioned Ray as a potential substrate.
Yeah. So, I mean, definitely Ant Financial is talking, I mentioned Jack Ma's companies and what they've done with Geobase and the rest. And, you see their talks, you see Charles Hay in his talks about what they've built out with Ray and how graph is an essential part. So for instance, you mentioned about money laundering. When you look back at the Panama Papers, the way that was, the sleuths were able to solve that by using graph technologies, because money laundering is a graph technology. You just keep pushing further and further out down the links so that nobody can find it. And so a lot of the finance people, they have these requirements globally for KYC, know your customer. And so if you are Ant Financial, you have enormous graph problems to compute when you're making microloans out to hundreds of millions of people. And they're using Ray. And I think that, gosh, I'm going to get myself in real trouble. When you look at the state of software engineering in the graph space, there's a lot of people who like, this project started in 1998. We're going to continue the tradition. So I mean, there's a lot of stuff that's like, oh my God, I can't believe. I mean, these are people who think that XML is a great idea. But then we look at like the hardware competency for a lot of this space. A lot of people that just don't have any clue what's going on with distributed systems and hardware. What Ray is doing is this ability to have composable futures and use async IO, use futures, and then be able to have distributed design patterns for actors and remote objects, remote functions, and it fits really well with graph processing. And so that's a lot of what our company has been working on lately, because well, again, I don't want to let the cat out of the bag, but there's a lot of room for Ray. Partly because Ray can also be very smart about the hardware. And so one of the things with graphs is that there are bottlenecks. There are bottlenecks in the lookups, and there are bottlenecks in terms of the compute. And both of those bottlenecks can be addressed with GPUs very readily. And so when you look to, like, for instance, I'll shout out to my friend Bradley Rees at NVIDIA, who leads the cuGraph team. Really amazing work of what they're doing, also with GraphBLAS and other components, ScoopEye and whatnot. Dask, cuDF, where they can leverage hardware. You have a big graph, you pull out the part you want to compute, you drop it into your cluster of GPUs, and then you get the results and you propagate it back into your bigger graph. And so Dean Wampler and I just did a report called Hardware is Greater Than Software, Greater Than Process, Data Science in a Post-Moore's Law World. And a big component of that is a chapter we have called Thinking Sparse and Dense. And so a lot of what's going on with Ray and with Rapids and with other contemporary data science, data engineering tools for machine learning that leverage hardware in a smart way is that notion of sparse and dense. There are times you want to be sparse and distributed on a big graph, and there are times when you're going to take a subset of data and just crunch it inside of GPUs. And a lot of the architectures for the graph technologies, they don't even know that this has happened. I mean, this is something really, it's changed a lot over the past 3 years. And I think that, there are still graph people living in 1998, but there are others who are still living in 2015. And so, a lot of what our company's been doing is consulting work with both Anyscale and NVIDIA, getting real hands-on in these technologies, but then going out to the use cases and getting different large enterprise use cases, getting those people to talk with each other about what do they really need, and then how can we take the current open source and hardware accelerators to approach it.
So we are quickly coming to a close, but I've got one more thing to talk about. You have both of you have peppered throughout the discussion some challenges that are brought by the graph technology. Most of them, so far, though, have been technical challenges. So what kinds of other challenges, like upskilling talent, data governance, maybe is addressed by the blockchain? But what kinds of other challenges do companies face?
I think it's actually the opposite, and I would contend that you can get the technologies to do what you need. You have to sort of wall off a lot of the graph database vendors for a moment, and then look at things like Ray and look at what's going on with Rapids and others. You can get the technologies you need. There are things like GraphBlast that are just amazing. So you can get the technologies, but upskilling your people, retraining your staff to be able to handle graph thinking, and getting executives on board with this so they don't see it as a threat, but rather as a way toward better profitability and less risk, that's the hard part. And that's where, when I talk with enterprise customers that are in these large practices, they spend most of their time on the social side. In fact, it's a lot of social engineering at this point, really, just to get people thinking differently and not running and screaming out the door.
So for me, I'm been really getting more excited about the use of graphs in ML, particularly graph neural networks. Those are really proving to be impressive in many situations, and there's many headline use cases that I'm sure a lot of our listeners have heard about. But as Paco pointed out, the tools are there, but they're not quite as commonplace as the tools for non-graph data. So maybe in the next couple of years, there will be more and more tools.
There'll be a book that helps.
Or a book, yeah. I mean, so there are initial libraries, DGL, PyTorch, PyTorch Geometric, but it'll require a little more. Let's see, examples, tutorials, and books like what Paco is going to do.
Our open source developer community, we've been leading workshops at a lot of different conferences. They're always really heavily attended, very popular. A lot of people come in. And again, we try to break this down so that the tools look like pandas and scikit-learn, but then they also speak well with Spark
or CSV files.
Yeah, exactly. It's not that hard. And it's really just, we want to think about the problem differently. I think that a lot of this space has just been so academic for so long, and now it's actually turning out to be practical. And we have the compute power to make it practical. So I've been really trying to evangelize and teach people about graph data science. And I do think that we're getting some recognition in non-tech industry.
And you know, Jen, it seems like in many areas of tech, just when they're on the cusp of really taking off, it takes people who are not as deeply emotionally embedded like Paco, who can go out there, and be a little more measured and a little more patient with new users, right? Because what happens is when you're deep into something, you just assume everything is obvious, right? So
right.
Yeah, a lot of these folks you wouldn't want to roll out. I'll mention one other thing along those lines, though, just to follow up. Gartner, even into like mid 2020, Gartner was putting graph technologies at like about the top of the trough of disillusionment, and they really weren't very glowing. In February, they did a very abrupt about face, and they came out with a report that said graph technologies represent about 10% penetration in data analytics and enterprise in 2020 or 2021. We project that will grow to over 80% by 2025. And they're currently seeing more than 50% of all AI inquiries that come into Gartner are about graph technologies. And there's like, and they really stress the point, you know, when you look at spreadsheets, you look at SQL queries, they have graphs under the hood, but the dirt's been swept under the rug. And it's that metadata and it's the business logic that's so crucial, especially in a world that's grappling with pandemics and climate change and everything else. those complexities have been swept under the rug for too long. And now graphs allow us to be able to take those complexities out of the pockets of the business and surface them so we can manipulate them and use
Yeah.
them for
Right.
AI.
Yeah, which actually, Paco, as you were talking there, I mean, going back to my pet peeve about CSV, I mean, I think, as I mentioned, people like it because it's readable and it's understandable. So we need kind of the equivalent thing for graphs, right? Like
Oh,
the equivalent of the
it's
spreadsheet, right?
well, definitely as far as a file format. The thing is brilliant.
Or
with
just
graphs is,
something that people can,
oh
uh,
yeah, the
you know what I
visual
mean?
side is visual.
Yeah.
So I will shout out to a friend, Leo Myrovich, common friend of ours.
Oh,
And
advisor.
yeah, actually, you're advisor for Graphistry. Graphistry is really brilliant in this area. I'll put in a big plug. It's one of my favorites. I think that the file format, though, Parquet is just brilliant for
Oh,
graphs.
yeah. Yeah.
Amazing. And the fact that there's so many vendors that are like still working with XML, and like you come in and literally like we can show 2 orders of magnitude increase over CSVs. It just it's mind-boggling to me.
Humans and users for some reason just love tables. They like looking at things on spreadsheets, scrolling down.
Those are the known knowns.
You know,
If you can put stuff into a grid, it's very easy to understand very simply without investing a lot of intellect into it.
just look at how powerful, how popular Airtable is. It's basically like a Google spreadsheet, right? So,
But there's a danger again in oversimplifying complex problems.
Yeah.
If your complex problem is you have 1,000 people working in a plant, and if somebody sets one control wrong, the whole thing blows up. Which with our customers, that's exactly their problem.
so
you definitely don't want to oversimplify that problem.
We need a graph people to come up with something that becomes so familiar to people, to regular users, right?
No, I disagree.
No?
Completely. I think that the graphs are really more for the domain experts, the people who
Yeah.
really understand what the hell's going on, and they're not for let's dumb it down and democratize it.
No, but I mean, but the ability to work with graphs so that it's much easier. And then,
yeah, probably some.
know.
I mean, there's definitely, like I say, I think that the sort of what will follow notebooks is making some good progress. I love Jupyter. I use Jupyter a lot. I've been involved in that community. But I think something will come after notebooks. And whatever it is, I think that we'll see much more of a graph component in that.
Yeah.
Definitely seeing some inklings of that already.
And Paco, just to close out, do you want to tell our listeners where they can find your workshops?
Certainly. Well, we will advertise them. I mean, I'm at Derwen, so DER.
Derwen.ai. Yep.
But I'm also very involved with some conferences, which are really great resources, have great communities. One of these is Connected Data World out of London, Europe, other parts of Europe, I should say, but mostly out of London. And so, there's a conference series there with meetups in between. Great community. And there's another one that's a really large community called the Knowledge Graph Conference, KGC. And KGC, we currently have, I think it was north of about 1,400 members. So if you jump onto Slack at KGC, if you have questions, you want to find people who can help you or maybe get involved with projects or learn about it, certainly the workshops and all that are there. I do monthly office hours. Some of the other experts do as well. We do a lot of Q&A for people as experts to try to help them grow. There's a lot of connection for grad students and whatnot. So these communities are being really super helpful. And there's also some other communities too, ISWC and ESIP and the federal space and a few others. But definitely, I think KGC is probably a good starting point.
All right. Well, thank you as always, Paco, for this fabulous episode.
Thank you, Jen. I appreciate it. Great talking to you.
Thank you.